आज का टॉपिक क्या है? What's today's topic?
Yeah. So today we will see sizing and quotas, wherein we gonna understand that sizing basically we mean that how to commission and decommission the nodes. So how to add we already seen. So in this model, sizing basically means how to add and remove nodes. Adding of the nodes is known as commissioning, and removing of the node is known as decommissioning. So in short, we're gonna see how to commission and decommission the nodes. In simple words, how to add and remove the nodes. Quotas is um, how to uh, prevent any user from monopolizing the capacity. In short, if you see the Google Drive, right? If you see the Google Drive, each one who has a Gmail account, they get 15 GB of capacity. Now, in this 15 GB of capacity, they can put either 10,000 files worth of size 15 GB, 10,000 files, or they can put one file of 15 GB. Okay. So in these quotas, we will see two kinds of quotas. One, name quota, and another is a space quota. The name itself says that the space quota will be quota based on the size and the or number of bytes you can store. That would be the most appropriate statement. Number of bytes you can store. And name quota is basically will depend on the number of files you can store. So there are two kinds of quotas which we are going to understand very soon. So that's the topic of that's the today's topic which we're gonna cover. So let us bring our cluster first. So I will go to my machine and I'll select each of those, start my instances. It will take some time to start my instance now. Okay, so meanwhile we'll start with some theoretical concepts. So in this module, we will see how to commission nodes. So in other words, how to commission data nodes and the node manager. So when we are commissioning a nodes, when we are adding a nodes, that means we are adding a slave machines. Of course, when you're adding a node, you cannot add a master machine, you have to add a slave machines. And slave machines, which means that it will run data node and the node manager. So we will see how to commission data node and node managers, and then how to decommission data node and node manager, that also we'll see. Then we'll see what do we mean by quotas and how to perform the quota accounting. This is important, how to do a quota accounting, which we'll see. It's an important topic. Commissioning, the name itself, commissioning, means that addition of nodes. But remember that it's basically in a simple term, commissioning means adding a new node. But remember that uh, any machine can become a part of the cluster if that machine knows address of the name node. And I hope now by this time you know which property specifies the address of the name node. fs.defaultFS. So anyone who knows the address of the name node, they can become a part of the cluster. So in any machine, you just need to specify. You just can download the tarball. You in the core-site.xml, you provide the address of this whatever fs.defaultFS, and then you start Hadoop data node. Hadoop data node. This is how you can manually start the data node process. This is a command, and it will start the data node process automatically. And this machine will become the part of the cluster. And you don't know whose machine is this. This could be a hacker machine. But once the machine becomes a part of the cluster, you will get the data, and the hacker has the access to your blocks, right? So this is not the in a real sense commissioning. Commissioning basically means that you know which all machines you are going to add. Administrator, when I say you, it's basically administrator knows which all machines can become a part of the cluster. So that's known as commissioning. The one commissioning basically means the name itself says that you know what you are doing. You know which machines can become a part of the cluster, right? So that's meaning of commissioning. But in a simple layman term, that's an addition of a new node. But if you want to define the commissioning, you can always say that graceful addition of the node, wherein one knows which machines are going to be part of the cluster. So whenever you add a new machine, why do you add a new machine? When, right, for what? For storage capacity, for increase in the storage capacity. And the second thing, when you add a new machine, you also get the processing capacity. So addition of a new node brings two things with him. One is the extra storage capacity, and the processing capacity. So the motivation of adding a new node is that you get additional storage capacity. It will increases the aggregate network IO bandwidth, which basically means that now your data will be more distributed, and more nodes. If you add more nodes, then your data will be now evenly spread, or whatever you can say. I mean, adding a new node is nothing but you get more storage capacity to add more blocks, and also in a scenario wherein few nodes have got all the blocks, you can run a HDFS balancer so that it is distributed across all the nodes. It reduces the impact of losing a single machine, of course, because addition of a new nodes. So your replicas will be stored in some other machine. Your replicas will be created, right? If you are under replicas, if you have some blocks as under replicated, then addition of a new machine, what will happen? Your blocks will become or come to a normal replication factor. I believe in the last class module I have clearly explained what is under replication over replication. And addition of a nodes is an online or a hot operation. It means that you don't have to stop the cluster. Or in other words, you say there is no disruption in the service when you add a new node. There is no disruption in the cluster activity when you add a node. It's an online or a hot operation. Decommissioning means graceful removal of the machine. Now, decommissioning is removal of machine, you can say, right? But anyone, if you decommissioning, or I would say the non-graceful decommission means non-graceful decommission means someone you enter into this machine, and say kill -9 the data node process ID. That's one thing. So you are forcefully killing the data node processes by using this kill -9. That's a non-graceful decommission. What will happen non-graceful decommission? Because this machine will stop responding, and after 10 minutes the name node will come to know that this data node has gone down, and after 10 minutes it will start replicating the blocks. That is why it's a non-graceful decommission. When we say decommission, it means graceful removal of machine. That means before the machine gets decommissioned, it will it will copy the blocks of data into some other machine, so that replication factor is intact and there is a little burden on the name node. So replication factor should be intact. It process could be lengthy. It will depend on the number of blocks the machine has. It will depend on the number of blocks the machine has. Lesser the machine, the process will be faster. If it has a more number of blocks, then the process will be lengthy, because it will result into network. It will result. I mean, it will take more time to copy the data, and it will result in increased network activity, because the data has to be copied to other machines over the network. Copied to other machines, to other data node machines over the network. That's why it will result in increased network activity. So that's overview of what do we mean by commissioning and decommissioning. Generally, when you do with the Apache Hadoop, then you use these properties. What you do, you create a property. Commissioning means graceful addition of a machine, where the administrator knows that which all machine can become a part of the cluster. Actually, administrator specifies the IP addresses range of those machines that can become part of the cluster, thereby preventing other machines to become to become a part of cluster. So what do you do actually in Apache Hadoop is you use the property dfs.hosts. The prefix of the property is dfs. That means you will specify this property in hdfs-site.xml. So you use this property. The value of this property is a file, and in this file you will provide the list of the IP addresses, one per line, and you run this command hadoop dfs admin-refresh nodes. For example, you provide the IP addresses like 10.0.0.1, 10.0.0.2, 10.0.0.3. So you have provided the IP addresses of 3 machines, and then you run this command hadoop dfs admin-refresh nodes. And please note that this particular file should be present on the name node machine. And once you run this command, you can go into each of these machines and you can run the command hadoop data node. Then it will start the data node processes on those machines automatically, and then there will be no cribbing. That because you have specified, you have informed the name node that these are the only set of IPs that can become a part of my cluster. Any other machine, any other IP addresses, like say for example, you go onto a machine which has an IP address of 10.0.4, which is not present in this list, and if you try starting the data node, if you try starting the data node process, then you will get an exception saying that data node disallowed exception. This is a specific exception you will get. In Ambari, what do? You don't have to do this activity. You will see that we just need to add the host, and we will just need to provide. We just need to add the host via Ambari UI, and then we can do it. We have already seen the previous classes. Okay, but also we can use this property also, not a problem. via Ambari, but in the Ambari also we can use this property, but we don't require it because from the Ambari UI it gives us the flexibility to add a new host. Similarly, in the for commissioning the node manager in the Apache Hadoop, you do like this. You use this property yarn.resource manager.includes path. Again, the value of this property is a file, and this property should be present on the. It's the same thing, but on the yarn on the yarn framework, and it should be present on resource manager. You will provide IP addresses one per line, and then you run this command yarn admin minus refresh nodes, so that resource manager knows the list of the IP addresses that can become a part of the cluster, or the list of the node managers that can contact the resource manager. And then you can go to each of these machines and you say yarn node manager, and these node manager that is going to start on all these machines can contact the resource manager, or else it will throw an exception. Okay, so let us see. It's already running. So now let me start my cluster. So I'll take up this public IP of my Apache Ambari machine. The port is 80. Oh, it's 8080. Username admin, password admin. And since all are red right now, you can see it here, all are red. You have to start all the processes. So you will click on this actions button, and then you'll say start all. And then you get an option of saying start all. So you click on this start all. You're about to start all the services, confirm start. You can always click on here, start all services, that what's happening. Right? And you can click on here to see what's happening. You can always click on the host section. So let it start and let all become first screen. So still the operation is running. You can always look out for the one op. You can see that right on the top here. So that means one operation is running. There are 13 alerts, and we'll see in the host section how many hosts are added. So meanwhile, what I will do, I'll bring up one more machine. I'll go to my I'll go to my AWS. I'll say launch instance. Quickly bring up one machine, and this is my this is always we have chosen this machine, so Red Hat Enterprise Linux 7.3. I'll say select. We require 64-bit, so this is our 64-bit, and we'll click on this select. This is fine. We have already been seeing this, so I'll go with the M3.X large machine, m3.x large. Right now I can always work with a smaller machine as well. So to this machine I can go with m3.large machine. Configure instance detail, I need only one instance. Yes. Add storage, I can go with the default storage. Add tags, so add a name tag. The name tag I can add a one tag, and this is my Ambari data node 0. Let's say configure security group. I will use all the, I would say, I can see, do I have the select? Let me see. I can use everything. Custom TCP rule, TCP 8080, all traffic. Yes, all traffic. I'll go with the all traffic are permitted, and I can see here my security groups. So the all traffic permitted from all the sources. So not a problem. I say launch now, and I will check out my PEM file which I already have. I acknowledge this and say launch instance. It will take some time. Meanwhile, let's go to our UI, Ambari UI, and we click on this, and we see that here I can always go to dashboard. From the dashboard itself, it's sufficient. You can see here, you see data nodes are 2 by 2, node managers 2 by 2, right? And let us also click on our HDFS on the left hand side here, HDFS, and then you go to quick links and click on the name node UI. You come down, and here a couple of things you should be now noting. Security is off. Okay, fine. We have not Kerberized our cluster. We have not enabled Kerberos. Safe mode is off. We know what is the safe mode now. And you should also look out for number of live nodes, which is 2, right? And here a couple of under replication blocks are there. 4 blocks are under replicated. Okay, that's fine. Okay, so now I think my machine should be up by this time. The new machine. So this is the new machine which I have, DN0, and I don't have to do anything. Let me just copy my private DNS. So this is my private DNS. The reason the private DNS will never change, only the public DNS will. Every time you reboot a machine, your public DNS will change. So we'll use private DNS, and we will go to our now this is a process of commissioning. So first we'll add a host. So you can see this host sections on top. We are going to click on this. You click on the host sections. Currently there are 2 hosts. Now what you do, you have to add a new host. So you can go to actions, and you have a add new host button here. So click on add new host, and you provide the host name here. So what is our host name? We have already copied. So this is our host name, and we will use our PEM file for the passwordless SSH. I forgot. Where's my PEM? AWS PEM. This is my PEM. and I'll use Hadoop training.pem. So that is a PEM, and we have not a, we are using EC2 instance. So we'll say EC2 hyphen user register and confirm. Okay, it will crypt because it does not have an NTP. So let it fail. It will say that a couple of warnings are there, so we have to resolve those warnings. So it will, I think the probably the NTP is not running, so I have to install NTP. So let us install NTP. Yeah. First we'll install the wget, and then we install the NTP. But before that, let us check whether it has thrown that exception, thrown that warning or not. So we'll click on this. You can see that some warnings were encountered while performing the checks against the one registered host. So click on see the warnings. All are fine, but it is a service issue problem, and NTPD is not running. So it's better we'll start the NTPD. We'll install NTPD. And then we will start sudo systemctl. Let us systemctl enable NTPD, and then we'll say start. Also, let us check the status should be active. It's always better to check the status of the services. So we can see here that it is active. Okay, then what we do here, we go back to our Ambari UI. We will say rerun the checks, and you can see its progress bar is running. Okay, host check successfully updated. So you can see that all are green here. You say close, and you also see a green bar here. You say next, and now please understand that we are um, adding a slave machine, right? Because already it's a part of the cluster. So whenever you add a new machine, it's basically you are adding a cluster, you're adding a slave machine. Now, and since we have chosen, if you remember, when we were installing this HDP, then we have chosen HDFS and the yarn, HDFS service and the yarn service. So automatically it gives us whether you want to install DataNode, NodeManager, and this is anyways default NFS gateway. And by default, it's a client. Remember that if you don't install the client, let's say this machine you are installing, and if you don't install the client, then from this machine you will not be able to run. From this machine you will not be able to run HDFS operations or the jobs. You will not be able to. able to run HDFS operations and also jobs. Map reduce job. If you are submitting, you'll not be able to do that. Okay, for the time being, let's say I will disable this.
So,
Don't want to add anything. Yeah.
I have one question here. Probably you might be repeating it again. So, when we enable the client, what is that extra it puts into that machine? Does it add any jar file, or what is
No,
that
no,
it
no.
does
Only
if
the
I enable the
commands.
client?
Hadoop commands, HDFS commands you can perform. It will know where to contact the name node. It will know where to contact the resource manager. Everything will be in a particular location. etc Hadoop file, etc Hadoop. It will put everything client configuration to etc Hadoop so that all the core hyphen cited XML where address of the name node is present. HDFS hyphen cited XML where your block size replication factors are present. Yarn, everything will be present under one thing. So whenever you run the command Hadoop FS, and whatever command you run, it knows where to contact it or it knows what to do and all. So all the client related configurations will be present inside this machine. If there are no client related properties, then it will not run it.
Okay. Yep. Thanks. So.
So let's say now I'll choose the client, but I'm not choosing anything. See that I'm not choosing anything. Let it be like that. I'm just adding a bare machine. I'm not adding this machine as a part of the cluster. I will add later also. So I'll show you that you can either choose right now. So it will start data node and the node manager by default. But I'm adding a new machine altogether without any processes. That's my intention. I'm not going to do anything. I have not chosen. Please see that I have not chosen to run any processes on this machine. Please see this is a blank. I have not checked. Okay. Later on I will add. I can click on next, deploy. There is nothing to deploy. It should be faster. It's only installing the clients. You can click on here to see what's happening. Okay. Anyways, it is downloading a package Hadoop 2.3. So you can see that it's a very big package, so it's going to take some time. So it has started, install and started the services, but we have not chosen any services to be started. I'll say next and complete. So if you see this, let us go to our dashboard, and there are only 2 by 2 of uh, NodeManager and DataNodes, right? Let us also go to host and check one by one. We'll click on one of the host, and it will say on the left hand side, you can see that it says what all components are installed here. It also gives you an option of adding. You can see add, and it says that what all things you can add. You can add NFS gateway and Zookeeper server. Let us go to the machine which we have just added. Now this is the machine which we have just added. I click on this machine. There's nothing is installed. You can see that. What I do here is I'll say add, and now this time what all things I want to add. I want to commission the data node. So I'll say add data node. Are you sure you want to add the data node? Yes, confirm add. And you can see that it will start installing the data node here. Ideally, it should display the logs. That's very weird. It doesn't display the logs. As after the completion of the entire process, it will display the logs. Okay, and if you see that you have just added, but you have not started, so that's why it is here in the red, and it is the state is stopped. What we will do is to start the data node. So I say start. So what you are saying is commissioning the data node, and there is as such no problem here. You can go to the dashboard, and you should see right now 3 out of 3 because it is still running. You see it's 3 of 3, but the node managers you have not added commissioning. You have not commissioned your node manager. Now you know what to do. You can go to your host section again. You can, this is the section, you can see this here. You can say add node manager. You say confirm add, and then you can start it up also. You say okay, and then you see that the node manager has been added, but it's just installed but not started. It's in start state. What you do, you go click on start button and say start, and it will ask you for the confirmation. Press OK. You go to dashboard and check. It should be refreshed by this time. It will take some time to refresh, but now you can see that it's a 3 of 3 node managers alive, 3 of 3 data nodes alive. So what you have done is you have commissioned data node and the node managers. I'll go to HDFS section, quick links. You might have observed that previously I have shown you number of under replicated blocks as 4 in the previous. That's why I have kept it open long back, the one before I have added the node. Now I have added the node, and I'll go to see this. The number of under replicated blocks is 0. So what you have seen, or what we have studied yesterday, is that one of the major responsibility of the name node is to keep the replication factor to a normal level. And what you have observed is as soon as we added a node, then the blocks which are under replicated, those gets created in the new node, and it becomes number of unreplicated blocks becomes 0. So that also this part also we have seen in action. Okay, this was my previous UI. If I refresh, this part will go automatically. So I have refreshed this page. Okay, so that's basically complete. So commissioning of node managers and data node. Now, what do we mean by decommissioning? As I previously explained, decommissioning is graceful removal of node, and and this process could be lengthy, which depends on the number of blocks the number of blocks the machine has. Also, the decommissioning will result into increased network activity because the blocks has to be copied to the other machine via network. So if you do in Apache Hadoop, you use this property dfs.exclude.hosts, and again it's the value of this property is a file, which should be present on the name node, and it will consist of the machines which you want to exclude it. And then you run this command hdfs dfs admin minus refresh nodes, and you will see that decommissioning will start in progress. Once decommissioned, the process automatically shuts down, and you will see that it will be removed. Okay, it will be removed in a sense. You will see that in the UI it will show you one less data node, and then you can also decommission your host altogether. Similarly, the same way we can decommission the node manager. In Apache Hadoop, you use this property yarn.resource-manager.nodes.exclude path. The value of this property is a file which is present, should be present in resource manager. Again, it should contain one IP address per line, and then you run this command yarn rm admin minus refresh nodes, which will tell the resource manager to exclude these IP machines. What we will do, we'll go to Ambari UI and we'll decommission our data nodes and the node manager. So I'll go to again host sections. I can check out, click on my host. I can say actions, selected host, data nodes, decommission. What I have done is I have first selected my host. Then I have clicked on my actions. I will go to selected hosts. And in the selected host, in the data node section, I want to decommission. This is what I want to do. I say decommission. It has started decommissioning. Are you sure you want to decommission? Yes, I am sure. So it will start decommissioning the data node. Meanwhile, I can go to, okay, we will see that. I can go to my Ambari UI to see that it will show me one data node is decommissioning state. Should show me, yeah, decommissioning nodes. It is 1. I'm trying to see here if I can see that one node is in decommission state. Yep, if I click on this, it says that one is decommissioning. Okay. Similarly, I go to my other machine. I again select my machine. I again select that machine. Go to actions, selected host, node manager, and I say decommission. So that's how you can decommission your node managers as well as data node. Once decommissioned, what I will do, I can remove this host from my cluster altogether. So what we have seen, we have added. So what we will do, first we have started with adding a machine. Then once the machine is added, we have commissioned our data node in the node manager. That's one part. And then we decommission our data node, we decommission our node manager, and then we delete our host from the cluster. I'll go to my, so one is decommissioning. Okay, let me, so here one is decommissioning. You can see that one is decommissioned already. And here also it will show after some time it has been decommissioned. So you should see 2 out of 3. I'll go to my host. Okay, and you can see that here the symbol has been changed. It's a warning symbol. And also it shows me one alert here. Yeah, I'll click on this, and can you see that here the data node and node managers are in decommission state. You can see the decommissioned. Here also decommissioned. What I want to do now is to delete this host from my cluster. So I'll go to host actions. I'll go to my host actions and I say delete host. This host cannot be deleted since the following components are running: DataNode and metrics manager. Okay, it still says that I cannot do that. It is in the stopped. It is not in the stopped state. Okay, let us wait for the stop state and then we'll delete the host. Okay, I can see that in the node manager it's decommissioned. I don't have the stop button, but here it's told me stop. That means it's still running. I will stop this metrics monitor.
So what is this Ambari matrices?
Whatever you see on the graphs, right? Can you see that the graphs?
Yeah.
This is the metrics monitor. So
Okay.
how much CPU, what's the RAM usage, memory usage, load, and those stuff.
Okay. Thanks, Om.
I think it's taking too time. What I can do here is, okay, I can say stop, let it go. That's not the way. It should take its own sweet time to stop it, but it's not taking. But so what I'm doing a hard stop here, and then I go here actions and delete host. Are you sure you want to delete the host? Okay. But important, by removing this host, Ambari will ignore future communication from this host. Of course, we want that. Software packages will not be removed. Okay, whatever I have installed, it will not be removed from the host. The components on the host should not be restarted. If you wish to re-add this host to cluster, be sure to clean the host. Okay, if you want to re-add this host after deleting it, you should clean the host. Warning: it says that the agent is still hard beating, so the host still exists in the database. To completely delete the host, first stop Ambari agent on it. Okay. If this host was hosting a Zookeeper server, the Zookeeper server should be dusted. Okay, that's fine. So to completely delete the host, first stop the Ambari agent on it. Okay. What I want to do here is, oh, it's got deleted. Yeah, automatically. Did I say deleted? Okay, I pressed OK. I can go to this machine and I can see ps minus ef grep Ambari agent. Okay, it's not running. Service Ambari agent start. Ambari agent status. Okay, it's still running. I can stop it. And now the host has been properly deleted. Yep. So that's basically, so if you see that here, the icon, it says that it requires a restart. Or else what we can do here, you can see, you can go to the dashboard section and you check out the services which has this symbol. That means they require restart. These services require restart.
So these services, when we are saying we have to do restart, is it across all the nodes or some particular node?
It's a service, right? It's a service level. These are the services. HDFS is a service which has three processes running: name node, data node, and the secondary name node. How many nodes you have? You have two machines you are running. So it will run one name node on one of the machine and data nodes on some other machine, right? It has to
Yeah.
start these processes. It's a service. On this, your
Uh,
service. Beyond service, it's a node resource manager and the node manager. So
yeah.
it will start those processes across all those machines.
But actually, my doubt is because commissioning and decommissioning, it should not do any alteration. Like the system should be online all the time. So,
It's
I mean,
online.
going by this,
It's not doing anything. It's an online operation. Are we starting it? Even if you don't restart, it's okay. But there will be stale configurations. The stale configurations are that it will keep that entry into its file. It will not restart. It will just say the stale configurations will be removed.
okay, okay, fine, fine, fine. Maybe it is doing some configuration cleanup.
Yeah, of
Okay.
course. And then see this. What does it say? Restart the stale configs. It is removing the stale configs.
Yes, yes, yes. Got it, Som.
Yeah. So it's still running. You can see that here. One op, and let it run first. And then what I'm gonna do is I can re-add the machine later, but we'll continue with the quotas.
Som, on the node which you deleted, there you stopped the Ambari agent.
Yeah.
I mean, what is that Ambari agent?
Whatever you're doing, right? Without Ambari agent, you cannot do it. It's an agent that is communicating with the Ambari server. So Ambari agent, all those host checking, everything it is done by the agent. It is
Agents.
responsible for sending the metrics. It is responsible for communicating the machine information to the master or Ambari server machine. So if the agent is
Oh,
not running, it will not be able to communicate with the server. So it
so,
is like lost. So agent is
oh,
so like we have a processes, right? Name node, data node communicates with the name node. Here Ambari agent communicates with the Ambari server.
okay. Yep.
Oh, okay.
Yes.
This is starting the
Got
name
it.
node. Yeah. Safe mode get. Safe mode is off. Okay, it's okay. Safe mode is off. I can meanwhile come restart this also. So once restarted, you can see that that particular symbol has gone. Restart symbol. Okay, let it get restarted. Now let us talk about quotas. Okay, so quotas, as I've explained you, it's like uh, uh, restriction on the disk space consumption. Quotas is like you are putting a restriction on the number of bytes that can be consumed by a user. You are putting a restriction. It can be consumed by a user. Okay, so it basically prevents the user from monopolizing the resources. So administrator can specify a limit. So you can specify a limit for a user. There are two kinds of limits. You can specify on the number of files and directories. That means to say that a user can how many files and directories he can keep. This is known as your name quota. That you can specify a name quota wherein you specify that okay, this user can put 5 files, 15 files. Now this 15 files can be one file can be a terabyte of file. So it you are putting on the restriction on the number of files. Here the second limit is you can specify the number of bytes used by the files, which is known as space quota. How much of a space that can be consumed. So if you say 15 GB as a space, then you can put 1000 files which is of worth of 15 GB, or you can put one file of 15 GB. So it is on the space, and here it is with respect to files. So on a particular directory, so administrator can, so for example you have one directory on HDFS. So on this directory you can have both the quotas. You can have the name quotas also, you can have the space quota also. How do I know what is amount of quota? Right now we have created, in the last class we have done couple of operations, right? So let us go to our let me take up this machine Apache Ambari. You can see my screen, guys, right?
Yes, so a bit delayed refresh, but we can see.
Okay, let me say HDF Hadoop fs minus ls, and on this directory I have a directory by name som. I would like to see how much of a quota is assigned to this particular is assigned on this particular directories. I have a command by name count. I just say Hadoop fs minus count to see that how to use it. You can say minus q minus h minus v minus t storage type and the path. Okay, I say now Hadoop fs minus count minus q minus h, that is for header, minus v for verbose. I'm not sure about the storage path here. So still not coming properly. Yeah, now this is better. Um, these are two with respect to the name quota. We have not specified any quota right now, so there is no quota specified. And infinite says that you can store infinite number of files in this directory. On this directory. This is with respect to the space quota. There is no space quota specified, and the remaining space quota says that infinity. It means that you can store infinite number of bytes. Now, name quota is a hard limit on the number of files. It's a hard limit on the number of files and directories on the number of files and directories in the tree rooted at the directory. So on a directory, on a given directory on HDFS, how many files and directories you can have inside it? That is basically name quota. And directories you can have inside this directory. The largest quota is your long dot maximum value. That's your infinity, which you are seeing 2 raised to the power 63 minus 1. Quotas are persistent in the FS image. So the quotas are persistent. That means that information is persistently stored. Okay, it will not be removed if you restart your cluster. Setting or removing a quota creates a journal or edits entry. So if you set or remove the quota, it will create an entry in the edits file. It will create an entry. It will create an entry in its file. Okay, because this changes the state of the HDFS. Because this operation changes the state of HDFS. That's why this information will be stored or persisted in the edits file. And how do you do that? Is by using this command. Let me just HDFS DFS admin minus set quota. You have three things, right? So it's an administrative command. Whenever I say administrative command, this operation needs to be performed by an administrator, not to a normal user. It cannot be performed by the normal user. This is HDFS DFS admin, and we are going to use these two commands: set quota, clear quota for the name quota. This is for the name quota. Hard limit on the number of directories and files. And there are two other things: set space quota and the set clear space quota. This is for the space quota. That is the hard limit on the number of bytes you can store. Okay. So let us create a quota, HDFS DFS admin minus set quota of 5 directories, or let's say 3 files on SOM. Oh, it says that set quota cannot be used by the EC2 user. Of course, the reason it is not, it's a normal user. So I have to go here and I say HDFS, because I am entering as a HDFS user. Then I can say HDFS DFS admin, because he is administrator user, minus set quota of 5 directory on user EC2 user. Under EC2 user we have a SOM directory. On that I am creating a quota of my 5 files. Exit, and now I will run the same command. So you can see that we have set the quota of 5. So it says the quota is a 5. Remaining quota is 3. So I believe there must be one file or one directory inside this SOM. Yes, I can see it from here. Directory count 1, file count 1. SOM is a directory, so that's why it itself is a one directory, and file count inside that it has a file count of 1. I think it's a comedies file. I believe under this file, under this directory I have a comedies file 1.7 MB. So 2. So 5 minus 2, 3. The remaining quota is 3. Let me just check what is there. Inside Hadoop, inside my SOM folder. Yeah, so there is one file by comedies. Okay, let me try putting the Shakespeare directory inside a SOM folder, which has now a quota of 5, and Shakespeare has 5 files. Will I be able to put it? you can see that after it has put 4 files, it will crypt. Let us see how many files it has put it. Hadoop fs minus ls. So okay, so it has went inside Shakespeare. Okay, under Shakespeare, how many files? It has kept comedies and glossaries, and after that it has started cribbing. That I cannot put. So there was a there was previously it was one song, then comedies is a second count, Shakespeare is a third, fourth, and fifth. So after fifth, everything it starts cribbing that I cannot put more than 5 because the quota is set to 5. Is that clear? Every directory and every file count will be counted. Is the name quota clear, guys? Are you guys there? Okay.
Yes, so
Now let us talk on the space quotas. So space quotas, as I've explained you, that it's a hard limit. It's a hard limit on the number of bytes used by the files in the tree rooted directory. On a given directory, you will put a space quota, let's say 15 MB or 15 GB. Then you can put files of worth 1000 files of worth 15 GB, or you can put one file of 1 GB. Then we will see that block allocation will fail if the quota would not allow a full block to be written. Okay, and each replica of a block counts for quota. So every replica will be counting for the quota. So we'll see how the quota accounting is done very soon. This is very important, quota accounting. So you need to remember that every replica will be counted. First thing, every replica will be counted. Second, you need to understand that name node or the name node will assume that entire block of data will be written, even though you are not writing. Entire block of data will be written. So keep this thing in. We'll keep these two things in mind and see that how the quota accounting is done. Okay. So let us do the exercise. What we will do is I'll create a directory, fresh directory, Hadoop fs minus mkdir, new directory. And on this particular directory, I'm going to set us I'll set a what do you say? I will set a quota of set space quota of 1 MB 1048576, 1 MB on this particular directory, user ec2 user new directory. And then I say hdfs, okay, Hadoop, what was the command? Hadoop fs minus count, yeah, new directory. And let us see this time we have specified, see this, the space quota. This is a space quota of 1 MB, remaining space quota of 1 MB. Directory count is 1 because it's itself count itself. It counts himself also. Okay, let me show you the size uh, of ls minus ltr Shakespeare, and I'm going to put the glossary file, which is a few KB, which is of a few KB. Some few KB, right? So if you put a glossary file which is a few KB with a replication factor of a 3, it will not exceed 1 MB, right? 58976 bytes into 3 will not exceed 1 MB. So ideally, I should be able to put my glossary file into a new directory folder which has a space quota of 1 MB. Let us try putting it. Hadoop fs minus put Shakespeare glossary in under new directory, and it says that quota exceed exception. It says that the put command has failed because the disk space quota is exceeded. The quota is this: you have assigned 108576 bytes, which is equal to 1 MB, but the disk space has consumed this much, 384 MB. So it has exceeded the quota. So where we went wrong? So what has went wrong basically? You see this error? Exceeded quota. Okay. So as I've explained in the previous slide, that you need quota accounting. Quota accounting is done in a way. So quota accounting, when the quota accounting is done, node assumes that full block will be written because we know how does the writing happen. Node does not know that how much of a block of data it is going to write. Right? It depends on your client. Client writes the data. So node assumes that full block will be written. Okay, and the second, every replication will be counted. So the glossary file which I was skipping was somewhere around some 0.5 some KB. Okay, so it will occupy only one block, right? It will occupy one block. So it will assume it will, if you put the file, it will have only one block. But this one block you have to assume it as a 120 MB block into 3. If you run that, if you calculate that, then it requires 384 megabytes. So if your quota, if on that particular directory, or whatever directory we have created, a new directory, if we set the quota of 384 MB and then we push the glossary file, then it will not create. So this is how the quota accounting is done. So let us put them. So I will say clear the space quota on that particular directory. And I'll again set the space quota, this time of 384 MB. So 1048576. That's 1 MB into 384. and then I try putting the glossary file, and this time it should not click. Yeah, it has successfully put my file. So this is how the quota accounting is done. You can follow the hands-on document and can see that what all. I mean, there are a lot of exercises in the hands-on document about this. Okay, you can take this as an assignment that specify the minimum quota, specify the minimum name and space quota on a directory to accommodate the Shakespeare data. Shakespeare data. So what you need to do, you first create a directory on HDFS, and on this directory, you have to specify minimum name quota and minimum space quota, not maximum. Maximum you cannot do. I'm a maximum if you provide, you will be able to put it. I want a minimum name and minimum space quota to be assigned so that you can put entire Shakespeare directory. Okay, so that you can take it as an assignment and you can do it on your own. So that's all from my side today, guys. And the next class we will talk about the HA, that about the name node HA and the yarn HA configurations, how to perform the high availability configurations in the next class. Thank you, guys.